last thing that I want to mention is some clinical points that you guys went over when you went through the class. And in that clinical points, I want to mention phosphofructokinase 1 deficiency that causes hemolytic anemia. And also, I want to mention, but for that, I prefer to explain the hemolytic anemia, explaining the next deficiency called allolase deficiency. In that case, you're going to have two types of allolase deficiency. You're going to have allolase deficiency A and allolase deficiency B. Allolase deficiency A, as the same as phosphofructokinase 1, will cause hemolytic anemia. What is the reason behind it? Well, remember that when we're talking about red blood cells does not have mitochondria, so they rely solemnly on anaerobic glycolysis. So if there is any defective enzyme in the process, there are going to be steps that are not going to be able to happen. So we are not going to get the necessary energy that the red blood cells needs to maintain osmolar regularity. I mean, in an extreme case, if a cell cannot maintain osmolar regularity, it can shrink or lyse. But in a more moderate deficiency, it will start to have an odd shape. And that odd shape are going to make that red blood cells to be stuck into circulation. And the generic name for that condition, well, hemolytic anemia. The second one is allolase deficiency B. In allolase deficiency B, it is very interesting because glycolysis and also gluconeogenesis for later, you can come with many intermediates that are not the primordial intermediates like amino acids and form the intermediates that are like in the main friendship. So what happens is that if you have deficiency in one of them, you're going to start to have accumulation of upstream intermediate. And one of them, it is fructose. In the case of fructose, fructose can be integrated after being transformed into glycolysis by this way. Fructose can be converted into fructose 1-phosphate, and fructose 1-phosphate can be converted into DHAP and glyceraldehyde, which later can be converted into G3P. But guess what enzyme does this step? The enzyme that does this step is called aldolase B. If aldolase B is deficient, well, you're not going to be able to break fructose 1-phosphate into DHAP and glyceraldehyde. So you're not going to be able to take energy from fructose because you're not going to be able to incorporate it into glycolysis through this process. So you're going to start to have accumulation and not be able to get energy from it. So you're going to start to have fructose intolerance. And well, guys, if you want more detail into the things that we have gone today here, I would highly recommend you to check the metabolic map with hormonal stimulation in the playlist. That goes very, very into detail. Next, we're going to go through gluconeogenesis. Thank you very much, guys.